Okay, here's a solution to number 78 in section 4.6 of Axler's pre-calculus book. Simplify the expression tan theta times the quantity 1 over 1 minus theta minus the quantity 1 over 1 plus cosine theta. Okay, so I'm taking the liberty of writing it out. And what I see when I see a 1 minus cosine theta or a 1 plus cosine theta is I see something that can be conjugated, something in the denominator with two terms and a plus or a minus. So what I'm going to do to start with is I'm going to leave the tan theta alone, and I'm going to multiply this by what some people call a clever 1. Okay? I'm going to multiply this whole thing times the conjugate of this, 1 plus cosine theta in the denominator. You can always multiply by that if you multiply by it in the numerator too. Minus 1 over 1 plus cosine theta. Well, what's the conjugate of this term? Again, you change that sign. The conjugate of 1 plus cosine theta is 1 minus cosine theta. It's fair to do that as long as you multiply it by it in the numerator too. If you're going to put a justification here, you would say something like multiplication by 1. That's always fair, right? Can always multiply by 1. Okay, so now I'm going to work out that multiplication. Tan theta stays put. Here you have 1 plus cosine theta over, the point of the conjugate is you get 1 times 1, which is 1. The cross terms cancel always when you conjugate. So 1 plus cosine theta minus cosine theta times 1, those cancel, minus cosine squared theta. Negative 1 minus cosine theta. Same thing happens over here. 1 times 1, cross terms cancel, minus cosine squared theta. Okay, so this is just true by distributivity and multiplication. So maybe I'll put a note there. Distributivity. I've distributed. And maybe I've also additively canceled terms. So and cancellation. Okay, so well, what can I see to simplify here? 1 minus cosine theta, you want to always be on the lookout for the Pythagorean identity. The Pythagorean identity classically is sine squared theta plus cosine squared theta equals 1. But if you see 1 minus cosine squared theta, it's just equal to sine squared theta. Okay, so I've got tan theta 1 plus cosine theta over sine squared theta minus 1 minus cosine theta over sine squared theta. Okay. Now I can combine these two things. They have a common denominator. So I'm going to combine fractions. Combined fractions. And I get tan theta equals 1 plus cosine theta minus 1 plus cosine theta over sine squared theta, right? So I combine those two things. And the 1 and the minus 1 cancel. So I think what I'm going to do is I'm going to write cosine tangent in terms of sine theta over cosine theta. So this is an alternate definition of tangent. And here, so I have some cancellation going on and an alternate description of tan. Tan theta equals sine theta over cosine theta. Okay, so these cancel, and I get 2 cosine theta over sine squared theta. I'm going to do a little more multiplicative cancellation. I've got a sine over sine squared. That leaves me with just a sine in the denominator. The 2 stays put. I have a cosine over a cosine, so that's just by cancellation. And then what's 1 over sine theta? That is, let's see, cosecant theta. And I believe that's the definition of cosecant. So I think we'd all agree that 2 times cosecant theta is a lot simpler than that.